So chapter 12, exercise 10, is asking you to draw the alkene produced by the different dehydration reactions. And with dehydration, you're basically going to be taking a water molecule off of an alcohol, and you'll be left with an alkene. So let's see what that looks like. I tend to think these problems are a little simpler when you draw them in the skeletal structure. And so to help me do that, I like to number them just so I can keep track of everything. I'm not numbering to name right now. Just 4 carbons here. So I'll draw 1, 2, 3, 4. Coming off that 4th carbon is an OH. So that would be the skeletal way of drawing this. And just for comparison, those are my different carbons there. Now you'll recognize this dehydration reaction because you'll have an alcohol, and that's a carbon chain that has an OH on it, and then over the arrow you'll have H plus and heat. Those are the signs to do the following steps. Now each of these carbons has a couple hydrogens on it. There's one hydrogen here. And what we're going to do is we're going to take this OH off, and we're going to take an H off next to it. And you can see how the OH and the H give you H2O, right? HOH or H2O. Same thing. So in this reaction, I'm just going to make a note of which carbons we're dealing with. We're dealing with the carbon that has the OH on it, and we're dealing with a carbon right next to it. So in a dehydration reaction, you take the OH off and the bond going to it. You take the H off and the bond going to it. And then between those two carbons that had the OH on it and the H on it, you draw a double bond. So the product here would look like this. And that would be the product you get at the alkene. Remember, an alk just means it's a hydrocarbon, and the ene just means you have a double bond. So the alkene you get from that dehydration reaction. Let's try it with a different molecule. The signs here, they do say in the problem, draw the alkene produced by each of the following dehydration reactions. So that's a good tip. But you could also recognize it because we have an alcohol and we have H plus and heat over the arrow. So what we're going to do here, let me just draw this here like so, H, and there is an H on one of these carbons next to it. And just for emphasis, I'm going to draw these in a different color. So what you do with a dehydration reaction is you erase the OH and the bond going to it. And let me just put as a reference a couple dots here. So erase the OH and the bond going to it, erase the H and the bond going to it, and make a second bond between the two carbons that had the OH and the H on them. So the product here would look like this. Notice it is an alkene, hydrocarbon that has a double bond. Okay. This one, again, I think would be clearer if you drew it in the skeletal structure. I like to do that, so I'm just going to number this so I can keep track of stuff. I have 5 carbons, so let me try that. I'm going to put a dot here. That's carbon number 1, 2, 3, 4, 5. I'll number them just to make sure. 3, 4, 5. And on carbon number 3, I have the OH. OH coming off. Now, on one of these carbons next to it, it doesn't matter which one you choose. You could choose the one to the right or to the left, but it has to be the one immediately next to it. There is a hydrogen coming off. We know it's a dehydration, first because it says in the problem, second because it has the H plus and heat and an alcohol. So what you do when it's a dehydration is and I'm going to put as a reference just where this OH and the H were. Erase the OH and the bond going to it, erase the H and the bond going to it, and create a second bond between the two carbons that had the OH and the H on them. So the answer for this one, the molecule you'd get, at this reaction would be this. And notice again, it is an alkene, a hydrocarbon that has a double bond.